Hello. So now today we're gonna work with some multi-dimensional arrays. Sometimes you want to have an array that's not just a vector. You want to have like a matrix or have it be multi-dimensional for some reason. Say in this instance we want to make a lattice, a three-dimensional cubic lattice. So we might want to do a three-dimensional array. Now you can use three-dimensional arrays uh, easily in C. That's fine. You do that. But sometimes to be more efficient with your code, and especially if they're very large arrays, it would be better to cast that large three-dimensional array into a or multi-dimensional array into a one-dimensional array. And that's what this little bit of code we're going to be working with does. I'll post this after we go through this video in the tutorials on Canvas. So we want to make a lattice, cubic lattice, each length 300. So it'll be 300 by 300 by 300. So we have this many spots in our lattice. Um, and maybe you want to fill them randomly. So we'll have some random numbers. Here's my random number generator. We're familiar with this function. Our new functions are right here. These are what we need to do. So obviously we need to do some transforms, right? Because we have a three-dimensional object or whatever representing in a one-dimensional way. So we needed ways to convert back. So your arrays have indexes. Those indexes, each individual index should point to a specific x, y, and z. So we need a function to go from index to coordinates. And also, if you get coordinates, like I have an x, y, and z, I need to know what index in my array that means. So we have to have these two functions: coordinate to index and index to coordinate. And coordinate to index is pretty simple. It just returns an index. You call your I in most arrays, and you give it an x, y, and z. So basically, what lattice spacing we are at, and it tells you what index that goes to. A little more complicated with the index coordinate because we're taking one number and making three numbers. So now it's void, but now I put this little 1 by 3 array. So that holds your x, y, and z. So I put in an index, and it gives me an x, y, and z, which will be held in this array. So we start with what we're going to call our array. I'm going to call it grid. I'm going to allocate it because it's going to be big. And this is primarily the reason why we're doing this casting, because it makes doing three-dimensional allocations a big pain, and it's not very memory efficient. Doing a nice 1D1 makes everything nice and simple. So here we go, 1D1. And this is going to represent our three-dimensional space. I'll go ahead and just zero everything out. Then I'm going to select some random x, y, and z inside our grid. So each side is L, so I just do an integer, random integer between 0 and L minus 1, which is what this will do here. So I get a random x, y, and z. And I say, well, what place in my grid is that? Well, place, so I use my coordinate to index function. I just give x, y, and z, and it gives me a place, and then I go here and say, hey, at that place, set that location to 1. This will be useful for the upcoming homework. And then I say, okay, maybe I do some math, and I say, well, what index is this guy here? Well, we can. So I say, okay, well, I know. I mean, what coordinates is this index? So okay, so I know. I know place. I know. So let's do index to coordinate function. Hit that right there, and it'll put in our R. And then when we come over here, so we go to print, and then we'll print our R, and they should be exactly the same. So let's just run that real quick. And okay, there we go. So my random number generator did 153, 69, and 168. And I run it through this machination here and just do the loop to confirm this is just, hey, this works. And yeah. Okay, so cool. So let's do an example of some math we can do with this. Okay, so we've overhead and we made our x, y, and z. We've got our place and got our index here. We set that equal to 1. Now we want to say, hey, let's set x equals x plus 1. So we're going to look at one space over. And then we can say, okay, we can come back to here. Just do some math. Oops. And then we can say, okay, what is, we can say, okay, we want to print F, that grid coordinate. So that's a, give it a new line. And then we'll give it a comma, and we're going to give grid of place. This should be a 0, obviously, because we've only placed 1. Yep. So that should print out whatever this one's in, and then now we print this. Our x should be incremented by 1 here. So let's build and see what happens. So to go over this, we set some random x, y, and z, put those coordinates to an index, set the grid at that index to 1, and say, okay, let's go to the next x. And then just look at that index. We get that index and say, okay, what is the value of that index? Well, it should be 0 because everything else was not set to 0 here, right? This is just playing with the code. So we're okay. Now let's take that index and get the coordinates for it. So when I print here, I should have x, y, z, and then I should have x, whatever x plus 1, and then y, z. So let's go ahead. Start debugging. Oh, yeah, well, duh. This x is the old x, so it's still going to be playing. But you see it incremented by 1, right? So here we get to 0, we expect. It was 153, now it's 154 for both of them. If we want to do this, we should, before we switch things up, we should have printed there, but that doesn't really matter. You get the idea. So I'll post this. This will be very helpful in the percolation assignment when we're actually filling a large grid randomly. So if you have any questions, let me know.